Newland octave model. Newland octave model was saying that is every eighth element. Okay, he was saying that is every eighth element are similar in properties with the first element. So this was.
Yes, sir.
Now next one is Lother Mayer curve model. Okay, sometimes the problem asks from this one, Lother Mayer curve model. Lother Mayer curve.
Yes, sir.
Ab, if you talk about Lother Mayer curve model, so how they have given the relation, you see. So Lother Mayer curve
Yes,
model,
sir.
they are saying when we plot, they are saying when we plot graph between, when we plot graph between atomic mass and atomic volume, atomic mass and atomic volume, atomic volume, then they are saying then similar element, similar elements, similar elements have similar position, have similar position, similar position in graph. This is what position in graph. Now, if you see, it means what? That is the, if you talk about that is the graph have how many things are there? Graph. So first one is there, peak is there. Okay, peak. So peak means they are saying all the alkali metal, alkali metal.
Yes, sir.
So these are alkali metals are there, all the alkali metal, and they are going to be the similar properties. This is the similar properties. This is the first point. Now the second one, they are saying, okay, if you are a
Yes, sir.
descending graph, DES, descending graph means coming downside. This is the descending graph. So if you are coming downside, so some one element will be there. They are saying alkaline earth metal. Here is alkaline earth metal. This is the earth metal. Okay, that is also they are having the similar properties. Next one, they are saying ascending graph. Okay, ascending graph. Here is little bit mistake, not that is descending, ascending, descending. This is the first one. This is the ascending, ASC. Ascending means going upward, and another is descending. If you are talking about descending, so that is halogens. Halogens. If you talk about halogens, they are also together have same properties. Next one, bottom of graph. Okay, or you can say the curve. So that is they are having bottom. If you are going, they are having transition metal in the bottom. What are elements are there? That is what is known as transition metal. This is transition metal. If we talk about transition metal, they are also having similar properties. Now you see,
Yes, sir.
first one is the peak of graph. If you take the peak of graph, all alkali metals are there. Like that is, if you
Yes.
see the lithium, sodium, potassium, rubidium, cesium, and francium. It means that is whatever the elements having on the peak, they should have the similar properties. Last day already I told you. Okay, yesterday I already told you. That is what I said. That is one group have that is similar properties. Like one class have similar properties, same one group have similar properties. The similarly, if you talk about the peak, whatever the peak will come, similar property. Let's try to write the relations. Suppose I am taking, here is atomic masses. This is the atomic masses of element. This is what. Now, second one, they are talking about volume. Volume of element. Element means,
Okay, sir.
so what they are saying, the initially how they are talking about this is the case. Then it is, then slowly it is increasing. Then here it is increasing. then you will find that it is keep on increasing. Here it is increasing. This one. So that is one. Now if you are assigning the position, so this is what is called as peak. This is the peak. Peak or the top.
Yes, sir.
Up top means what? Alkali metal are there. Alkali metal. Alkali. They are
Yes,
we are
sir.
alkali metals. Alkali metals are there. So what are there? Here is the lithium is there. Then sodium is there. Potassium, rubidium, and here is cesium. If you are saying
Hmm.
ascending,
Yes,
ascending
sir.
up, if you are talking about ascending, so this is the ascending one. Here it is also ascending, ascending, going upward. Ascending means going upward. So going upward means which element can be there? So it is the beryllium, then it can be the magnesium, then here is aluminum, then here is silicon. No, 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 no. Beryllium, magnesium, then calcium will come. Okay, group.
Calcium.
Calcium is strontium and this is barium. Next one, descending, coming down. Okay, volume is decreasing. So this is also
Yes,
coming
sir.
down. If you are talking about coming down, so that is coming down means it is can be halogen, fluorine, then it is going to be chlorine. Here is it is going to be bromine, then it is iodine. Okay, then it is astatine. These are their
Yes, sir.
bottom. Bottom they are saying transition metals like it is scandium. Okay, titanium. Here is vanadium, chromium. Here is manganese, iron. Here is cobalt. Now, so if you classify this one, pick one. So pick one. What are there? Only one we are classify pick. Suppose that is alkali metal are there. Alkali metal. So they are having the similar position, na? Top. All have top position. So all are top. They all are at top. So all are at top means what it is going to be? All are at top means all have same property. All have similar properties. This is going to be all have similar property. This is what the point. All have similar properties. Now, what are the properties which are similar? If I will ask, that is, how can you say that is that they have similar properties? So suppose you are having the lithium, then sodium, then potassium, rubidium, cesium. So it is 3, 11, 19, 37, 55. So if you go, that is 2 and 1. So one valence electron. Here is 2, 8, 1. Here is one valence electron. Here is 2, 8, 8, 1. Again valence electron 1. So 2, 8, 8, 18 and 1. Okay. Similarly, here you can say 2, 8, 8, 18. It is also going to be 18. Okay, space is less. Here is again 18 and 1. So you will, what you are finding, they have the same number of valence electron. So same number of valence electron means similar chemical properties. What properties? Similar property. If you talk about
Similar
now,
chemical.
if you see that is how many bond they are going to form, one bond, because one valence electron. They will complete the octet by transfer of electron. They are, they will remove the electron. So if they are removing the electron, so they are the metal. All are metals.
Yes, sir.
So they are having similar properties. So this is all about the Lother Mayer curve model. So they are saying when we plot graph between atomic masses and atomic volume, then similar element have similar position in graph. What are this one? Peak if you talk about alkali metal. Okay, similar properties. Ascending, alkaline earth metal. Descending, halogen. Bottom of the graph, transition metal. Getting my point? Are you be able to understand this one?
Yes, sir.
Okay. So right. So what you want? You want to write or should I send you the PDF?
Send.
Okay, so I will send you the PDF. Okay, for this one. Now this model also failed. Okay, failure of क्या, that is Lother Mayer model. Failure of Lother Mayer model. So what the failure, if you talk about the failure of Lother Mayer model, so what are the first point? If you see the first failure, it is not possible. It is not possible. It is not possible to represent. It is not possible to represent what? It is not possible to represent all the elements. Not possible to represent all the elements on the graph. On the graph. Okay. So this model fails. So this model fails. Second one. In some cases, the position of different element, position of different properties element occupies similar position. This. So this is what the all about. Okay. So in some cases, if you talk, so there that is what you are finding. That is, if properties are different but position are same, so we cannot qualify. So these are the two two reasons behind the failure of Lother Mayer curve model. So this is all about the Lother Mayer curve model. Let us try how the question asked. In the NEET exam, they will ask that is in Lother Mayer curve model, what
Yes, sir.
criteria were taken to arrange the element. So that is atomic mass and atomic volume. Sometimes the option is given atomic number or some other things will be given that are the wrong. Okay. The correct answer will be atomic mass versus atomic volume. Is it okay? Now next one is Mendeleev's periodic table. This is also got failed. This table is also got failed. So Mendeleev periodic table. Okay. Now, when you talk about this one, Mendeleev periodic table, so that is the law is there, Mendeleev periodic law. He gave that is Mendeleev periodic law. This was the one of the developed periodic table on during this time. Okay, compared to other periodic table, this was very much useful. Mendeleev periodic law. We are going to write the
Yes.
Mendeleev periodic law. So law means we need to memorize. Mendeleev periodic law means we have to memorize. So what the law is they are stating, that is physical and, they are saying physical and chemical properties of element, physical and chemical properties of elements are periodic function of are periodic function of atomic mass. Getting my point? So let's try to understand. They are saying physical and chemical properties of elements are periodic function of atomic masses. That is, how can we write in the different statement if you want to write in different statement? So let's write when elements are arranged in increasing order of their arranged in increasing order of their atomic masses then after certain interval, what they are saying, after certain interval, they are saying that after certain interval properties of element repeated. Properties of elements, properties of elements gets repeated. This is what gets repeated. Now, let's try to understand what is the meaning of this one if you talk about the meaning. So they are saying that is when elements are arranged in increasing order of their atomic masses, then after certain interval, properties of elements get repeated. Is it okay? Are you be able to understand?
Yes. Yes.
Okay. So now see, that is the Mendeleev periodic table. What are the Mendeleev periodic table? Okay. So come, no, here is the characters we have to write. That is characters of Mendeleev periodic table. Characters. Characters of Mendeleev
Mm.
periodic table. So what are the characters that is important? Characters of Mendeleev periodic table. First, that is the, if you talk about the first characters, that is this periodic table. This periodic table. This periodic table was based on increasing order of atomic masses of element. Atomic masses of element. This is what the first point. Point number 2. Similar group, same group, in one group, you write in one group, okay, elements of similar properties arranged. In one group, elements of similar properties arranged. Similar properties kept. Now, you can say that is kept or you can say that is present. That is both are the same. Means in the given group, what will be there? Elements of similar, elements of what they are saying. In one group, elements of similar properties will be present. That will be. Different properties elements will not be there. Suppose if you are I'm talking about, that is group 1. So what we will be there? It will be that is the, if suppose we are having group 1. So group 1 means that is lithium, sodium, potassium, rubidium. So these elements are there. So they are that is elements of similar property. They are what? They are going to be what? Elements of what? Similar property. This is what point. Similar property. How these elements are arranged? That is increasing order of atomic masses. Increasing order of atomic masses. Are you be able to understand this?
Yes, sir.
Okay. Now, on point number 3, 43. In this periodic table, in this periodic table, there are 0, you write that is 8 and 0 group present. 1 to 8, 1 to 8 and 0 group present. 0 group present. This many group present. Here is 0 group kept, when it is kept, 0 group kept later. Okay, so 0 group kept, that is very later. Okay, after the discovery of noble gases. Okay, so 1 to 8 groups are there. Point number 4. Group 1 to 7, this is the quite important. This is point important. So group, what they are saying, group 1 to 7, group 1 to 7 are, group 1 to 7 are, what we can say, group 2 1 to 7 are subdivided into two subgroups, subdivided into two subgroup, two subgroup two subgroup A and B. Two subgroup A and B. Now, fifth number. Group 8 is subdivided. Group 8 is subdivided into how many group they are saying? Group 8 is subdivided into three subgroup. Three subgroup. While group 0 is not divided. While group 0 is not divided. Not divided. Okay. So this is the point that you need to keep in mind. That 1 to 7 subdivided into two subgroup A and B. Group 8 is divided into 3 and group 0 is not divided. So these are the points. Now the next one, 6 number, important point. 6, very, very important for the exam. In this periodic table, some gap were left. Some gap were left for what? Were left for those elements. They are saying for those elements which were not discovered, which were not discovered at that time. Not discovered at that time. Okay. So he left some place also, for those elements which were not discovered at that time. What are this one? Like that is, they are saying EKA, Eka aluminum, or you can, that is Eka boron is there. Okay. Next one is, that is Eka aluminum is there, aluminium. Okay. One is there, Eka silicon. So these many three gaps he left. Okay, because the elements were not discovered. So he left the name, he put it the name, also defined the properties, but the element were not discovered. What are the, after that, what become the name? So they got Eka boron become, this Eka boron become the scandium. Okay, scandium, DIUM. This is the scandium is going to take the place of this one, scandium. Okay, so Eka boron become scandium. What become aluminium? If we talk about the Eka aluminium become gallium. Eka aluminium become gallium. Now silicon, if you talk about the Eka silicon, okay, let me see, that is Eka aluminium, Eka silicon is germanium. So these were the gap he left. Some places, three examples has been given. That is what the gap he left. So that gap name he gave, that is Eka boron, Eka aluminum, Eka silicon. Eka boron gap is occupied by scandium, Eka aluminum occupied by gallium, and Eka silicon is occupied by germanium. These are the options. Okay, answers. Can you understand this one, or this point?
Yes, sir.
Okay. Now if you see the next one, let us try to go for the point number 7. Point 7. So what in this periodic table, in this periodic table, there are, in this periodic table, there are 7, there are 7 periods in which, okay, 4, 5, 6. You can, not 7, it's 6. So 4, 5, 6 period in which 4, 5, and 6 are, you need to watch this one in the, no, it is 7 is there only. Some book you will find that is 6 are there, but in some book it is 7. In which 4, 5, 6, and 7, 4, 5, 6, and 7 are subdivided into 2 subperiods. 4, 5, 6, and 7 are subdivided into subdivided into two sub period, two sub period. Okay, two sub period. So these are the point are there. Now, whatever the period are there, suppose this is the period number, period. So period 1, comma 2, and 3, undivided. This is not undivided. You can watch in your book also, undivided. And if you talk of 4, 5, 6, and 7, it is divided into 2. Okay, divided into 2. So this into 2 sub period. So these were the characteristics of the Mendeleev periodic table, right? Now, if you see the structure, I am not diagram is not important for this one. Okay. Next one is the point is there failure, failure, failure of Mendeleev periodic table, failure of Mendeleev's periodic table. Why this table failed? Periodic table. Okay. So the first one, after, okay, after knowing the, after knowing the properties, after knowing the properties, what properties if we talk about, after knowing the properties of elements, after knowing the properties of elements that, after knowing the properties of elements that, what, after knowing the properties of element that, what we can say that the main properties is, the main properties is, what is the main properties if we talk about? The main properties of element, main properties of elements are what going to be atomic number. This is going to be atomic number, not atomic mass. It's not going to be atomic mass. Okay, that you need to keep in mind. That is, that if you see the Mendeleev periodic table, how they are going to arrange. The Mendeleev arranged this periodic table on the basis of atomic masses. But what happened after knowing the properties of element, that the main properties of element are atomic number and not atomic mass, and not atomic mass, this periodic table failed. Are you be able to understand the point? This periodic table failed. Is it okay? Janab, is
Yeah.
it?
Yes, sir.
Okay, good. Now, if you see the next one, if you see the next one, what can be the next one, next failure? Okay, some elements, some elements, some elements have atomic mass more. Some elements have atomic mass. What is there? Atomic mass more. But what they are saying, but the point they are saying, but they are kept before. They are kept before. Kept before. Okay. So some cases what we find, that is atomic mass over going to be the increasing order, but he kept some element in the case of decreasing order also. Okay. So where we can find this one, let me tell you this one. Okay. If you see which element, tellurium, if you see example, example is there Te. Te mass is how much they are saying 127.6. Okay, this is before is there, and the next element is what they are saying, that is iodine is there. Okay, and iodine mass is how much 126.9. So he said that is the elements are arranged in increasing order of atomic mass. But what happened? It is the more than this one. So it becomes the decreasing order. It becomes decreasing order. So some elements have atomic mass more but kept before. Is it okay? Is it okay? Are you be able to understand point number 1 and 2, Janab?
Yes, sir.
Okay. So let's try to go for the next point. What are there? Point number 3. Okay. Mendeleev. If we talk about the Mendeleev, okay, Mendeleev, do not give, Mendeleev, do not give different position for isotope. You know, different position for isotope. Different position for isotopes. They are saying they didn't give the different position for isotopes, even even though even though even though they have what different masses, even though they have different masses. Now, what are isotopes? Can you tell me what are the isotopes? What are isotopes, Janab? Hmm? What are isotopes?
Sir, they have similar mass number,
Hmm. Atomic number. They have same atomic number.
atomic number. Sorry.
Same atomic number. Okay, they have same atomic number and different mass number. Okay, this is going to be different mass number. Different mass number. And last one is they are they are atoms of same element. They are atoms of same element. Okay, so somewhat you know very well. Okay, suppose they are saying hydrogen. If we talk about hydrogen, so hydrogen have three isotopes. Okay, so first one is 1H1, then 1H2, and then 1H3. So 1, 2, 3 mass are there, hydrogen. Okay, 1, 2, 3 mass are there. So what we are talking about this one, what we can say this one, that is they have the three mass, three different mass, three different mass. So it should have, it should have what? Three different place. It should have three different place. Okay, it should have three different place. Why it should have three different place? Because the Mendeleev periodic tables are arranged in increasing order. Increasing order. Okay, Mendeleev periodic table arranged in increasing order of atomic masses. So it should have, okay, three different position. Because here if you see, that is, this is what is called protium. Okay, here is, this is 1H1 is there. This is called protium. But hydrogen element 1H2 is there, that is called deuterium. This is the deuterium. And last one is 1H3 is there, that is called tritium. Now, same element, although same element, but mass are differing, na? Increasing masses, increasing masses. So if the mass are different, increasing masses, so it should be placed in different places. It should be kept in the different places. Yes, Yano, tell me. It should be kept in different places. Yes, Yano. But
Yes, sir.
but it is kept in the same place, that is the not the correct one, because okay, we cannot keep them in the different places. That is what the point. Now let us try to check, check the fourth failure, fourth one. The fourth one, Mendeleev Mendeleev gives Mendeleev gives different, what he gives, that is different position. Mendeleev gives different position. No, Mendeleev gives different position to. So what he gave the different position, if we talk about the Mendeleev gave different position to isobars, okay, isobars, even though, we talk about even though they have, they have same mass, okay, same mass. What the law is there? Law is saying increasing order of the mass. We have to arrange the element in increasing order of the mass. But what they are, what the point he did, even though isobars means what? Same mass. Now, if we talk about isobar, so isobars means what? Same mass number. They are having the same mass number, same mass. Same mass. And what are the different? Same mass, different atomic number, same mass, and different atomic number. This is going to be what? different atomic number. Okay, this is case of the isobar. So let's try to understand. Okay, so how can you be able to understand this one? Suppose we are having that is argon. You start from the potassium. Okay, potassium. Potassium is that is 19 and it is 40. Then if you are talking about argon, argon is 18, it is 40. Next one is calcium, 40 and 20. So if you see this all the places, what you are finding? Mass is 40, mass is 40, and mass is 40. So they have same mass. They have same mass. But why kept? But why kept different places? Why kept different places? Why kept different places were wrong? This is going to be what? Were wrong. Because the rule is saying increasing order of the mass. Same mass means we have to keep the same places. But he kept in different places without explanation. That is why this model of periodic table failed. Is it okay? Is it okay? Jana, audible?
Sir.
Okay. Okay. So next point, if you see the next point, what is the point number last? Okay. That is fifth one. Okay. What is the fifth one? If you see the fifth point, that is group 1, 2. Group 1 to 7 each subdivided into group 1 to 7 is subdivided into two subgroup. Okay, two subgroup. But they are saying, but why? They are asking, but why group 8? But why group 8 is subdivided into 3? Group 8 is subdivided into what they are talking about, subdivided into 3 subgroups. Okay, 3 subgroups, and group 0 is undivided, and group 0 is undivided, which was not explained, which was not explained. So because of these things, this periodic table failed. Getting my point? Is this clear to you? This one Mendeleev periodic table and Lother Mayer curve model. This two periodic table.
Yes, sir.
Okay. So total 3 we have studied. Total actually 4. First one is Dominion triads model. Second one is Newland model. Third one is Lother Mayer model, and fourth one is Mendeleev periodic table. Right. So what we have to understand, what we have to do, we have to practice these things. Okay. Then only it will be the helpful to you to. Okay. Then only it is going to helpful. So let me make a pic of this so that I can show you in spite of the diagram, making the diagram of this. Wait a minute. I'm not asking you any of the question. Why? Because you are very good in study. That is what I'm thinking. So you keep on studying, please. Okay.
Yes, sir. Sure.
So here is. I will share that one. That will be the problem. So all the written will be disappear. Okay, leave it. Next one is there. What we are having, that is modern periodic table. This is the modern periodic table. I was planned to share the PDF, but if I will share, that is what I wrote, that is all will disappear. So I'm not sharing. Modern periodic table, that is also known as long form periodic table. Long form periodic table. This is also known as long form periodic table. Okay. This is both are the same name. Any name is correct. Whether you say that is modern periodic table, or you are saying long form periodic table, or up to whatever you want to say, you can say. Now, if you talk about the long form periodic table given by Moseley, okay, given by Moseley, Moseley, given by Moseley, okay, that you need to keep in mind. Moseley. So this is the point, because Moseley discovered the atomic number, so he give this periodic table. He failed all the, that is what Mendeleev periodic table was failed by Moseley, because when the Moseley was discovering characteristics of atom, so what he find, that is the main characteristics of atom is the atomic number, not the atomic mass. So that Moseley failed the Mendeleev periodic table and given the long form periodic table. What is there? The first one is, that is law. What was the law? See, physical and, they are saying physical and chemical, right? Physical and chemical properties of element. Here I am writing physical and chemical properties of elements. Physical and chemical properties of elements are periodic function of, or periodic function of what we can, physical and chemical properties of element are periodic function of atomic number. Okay, atomic number. Now, see, this has been changed. Earlier, what was there in Mendeleev, it was different. Physical and chemical properties of elements are periodic function of atomic number. Okay, this is atomic number. Earlier, you see what was there in the case of Mendeleev periodic table. They are saying physical and, here see, physical physical and chemical properties of elements are periodic function of atomic mass. Here it is changed. But if we talk about this one, today's one, so this is what is there. It is a atomic number. Are you be able to understand this one? Okay, good. So what we are going to do, I am changing this one another way. What is the changing one? Or the same law can be represented in different format. How? When elements are, when elements are arranged in, when elements are arranged in increasing order of, increasing order of atomic masses, increasing order of atomic masses. No, not atomic masses, it will be wrong. Increasing order of atomic numbers. Then after certain interval, then after certain interval, properties of element get repeated. Properties of elements gets repeated. Properties of elements gets repeated. Okay. So what they are saying, what the point they are saying, that when you are arranging the element, okay, when elements are arranged in increasing order of atomic number, then after certain interval, properties of elements get repeated. That is what the point we need to keep in mind. Okay, that is the properties of element are going to get repeated. Okay, when we are, okay, when we are arranging in increasing order of atomic numbers. Okay, so let's try to draw this periodic table. Kindly you also draw this periodic table, okay, if possible. So here you see, this is what the periodic table, that is how, so that we will write the character later on. Tomorrow we will write, not today, because it more matter means if it will go one, this is the period number. I will write that is what is period, what is group. Period means left to right. Okay, horizontal row. Group means vertical column. So it is 1, This is 3. Here is 4. This is going to be the 5. Next one is going to be 6. Another is going to be 7. This is okay. Here is what are point. Now, when the 1, 2, 3, 4. After that, this is getting start from the more element. Okay, how these periodic tables are there, that we need to understand. Can draw it like that. Okay, on the top, one more elements are there. Here, the 6 are there. You can make it out. So 1, here is it is going to be the 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And last one is going to, this is the 6. Okay, here is what are there. Here. So these are the, now this has to be extended form. Here is completely going to be extend. It is also going to extend. It is also going to extend, and this is going to match up here. Now these are there. Now what the problem here? These are the in between 10 groups are there. What are the 10 groups? Here you see 1. Okay. Here is going to be 2. This is going to be 3. This is going to be 4. Here is this is the 5. Here this is the 6. There is 7, 8, 9, and 10. So here group number, this is going to be 1. Here is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is going to be 13, 14, 15, 16, 17, and 18. Right. So if you talk about total group in this periodic table, total group, how many total groups are there? Total groups are 18. Okay. Total period. They are talking about total period. So how many periods are there? 7. Okay. So total groups are 18. Total period are 7. If you see this one, what are these points? Okay. So this one, this 1 and 2. This is 1 and 2 are known as S block. S block. And if you talk about this one, the 10 groups are there. These 10 group are known as D block. They are the D block. And if you talk about this one, okay, they are known as what? Going to be P block. So if we talk about the S block, how many groups are there? That you need to keep in mind 2 groups. D block, how many groups are there? 10 groups. E block, how many groups are there? That is going to be 6 groups. F block are the downside are there that we will draw next class. So here if you are filling, that is hydrogen. Here is going to be helium. If you talk about lithium, here is beryllium. This is going to be boron, carbon, nitrogen, oxygen, fluorine, and neon. Here you see sodium, magnesium. Here you are talking about aluminum, silicon, phosphorus, sulfur, chlorine, argon. Here you see, here is potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton. This one. So remaining you can fill it out. What is that is? Lithium, sodium, potassium. Here is rubidium, cesium, francium, beryllium, magnesium, calcium. Here is strontium is there. This one is the strontium. We talk about this one. Oxygen, sulfur, selenium, tellurium, and polonium is there. Fluorine, chromine, bromine, iodine, and astatine. If we talk about helium, helium, neon, argon, krypton, okay, xenon, and radon. So these many elements are there. Okay, so kindly what you do, Janab, can you make this one? I will send you, although I will send you, but you need to make this one so that you can understand. Okay, so remaining can we study tomorrow? If you don't mind, we can study
Yes,
tomorrow. Because
yes.
the one day it is only theory, na? It will not go in mind. Too much matter will not go in mind. So we'll be discussing the long form periodic table tomorrow. What you need to do, this long form periodic table, you kindly draw. I will share you the PDF, this PDF. You said to
Sir.
share me. You said to share me the problems here. You didn't share from your book.
Sorry, sir. I forgot I was busy.
Okay, okay. Today you share now. Today. Some problems you share, not the matter you need not to share. Okay, what are the questions are there now? Getting my point? In your Chaitanya book, what are the questions? Only question. I think question will be hardly will be 5 to 10 pages that you send, right? Hello.
Okay.
Okay, so okay, bye, take care.
Thank you, sir.
Welcome. You have M. गणित अरे